AC current flow analogy. In the realm of electrical theory, analogies are sometimes used to help students understand the flow of current in an alternating current AC system. A student of electricity will likely, at some point in instruction, be introduced to the flowing water analogy or the waterfall analogy. These analogies are useful, but only to a degree. With AC, current actually travels back and forth. So as far as analogies go, you would technically need one that can accommodate that unique aspect of AC. With this fact in mind, I developed the traveling workers analogy. For demonstration purposes, I take a snapshot, that is, one given moment, of current flow and delineate how my idea works. Granted, my analogy isn't perfect, but I'm reasonably sure that some students will be able to relate to it. Now, my disclaimer is I'm not an electrician, I'm not a professional, I'm not qualified to teach anything. All I'm doing is sharing an idea that I created a long time ago to help me understand electricity in my home. And also, when you're working on anything electrical in your home, turn off the power first. That's the most important thing. So the analogy goes like this. Our transformer would represent the main facility. The conductors would be roads. The service entrance panel would be an arrangement of connected roads. This figure of a light bulb, a load, would be your job site. And here's a job site. So what you have is a work order is put out, and they have to send out 15 workers, okay? 1 amp equal 1 worker. 15 workers leave the facility. They drive to the facility. They turn here and they go to the facility. 15 workers, and they do the job. They complete the job, all right? Then they know that they can't go back right away. They have to go to another job. So they go on this road here, right? And your panel, this would be your neutral setup. They go up here and they follow this. They follow this all the way to the next job site or the next load in electrical terms, right? They do their work. All 15 men do their work because this job requires 15 men, 15 qualified men. They finish the job and they leave on this road here, and they all go back to the main facility. Now, in electrical terms, you would call this, excuse me, you would call this a balanced load. You have 15 amps going this way, and you have 15 amps going that way. And remember, this is just a snapshot of electrical current flow. This is just one moment in time. So now we have a situation where the men are told, well, you have a job to go to, and we need 20 of you. So 20 men are sent out from the main facility, right? They go down here like this, and they turn, and 20 men go to the job site, and they do the job. They complete the job, right? Then they leave, they go back this way, and they get to this point, and they know that they have another job, but it requires only 15 men. So 15 men turn and go to the job site, and 5 of the men that aren't needed go back this way to the main facility. That's how they go back. So you have 5 men going back this way, 5 men continue on to the next job site. They do the work is completed, and they go back to the main facility this way. Those 15 men, and everybody's back at the main facility. So 20 went out, but when they came back, 5 came back this way, and 15 came back that way. Okay? Now let's look at another one. Here's a big job, and 24 men are needed for this job. All right, so 24 men leave, they go out of the main facility, they go down here, and 24 men turn into the job site. But when they get to the job site, there's all different obligations here, different things that need to be done. All right? 18 of those men, all right, 18 workers will need to work on the heating element. Let's say this is a giant dryer. That's a dryer symbol. So 18 men work on the heating element. They do their work, they complete it. And 6 workers are needed for other stuff. 5 workers are needed to work on the motor. 5 workers are needed to set up the motor. And 1 worker is needed to run the controls. So now you see you have 24 workers coming in, but there's different functions, different jobs here. So when they're done, when the work is completed, 18 workers leave. They go out this way, and they go out this straight path back to the main facility. 6 workers go on this road, right? This would be your neutral in your service entrance panel. And you say, well, what's the deal here? Why are they going this way? Well, in the analogy in real life, let's say these 6 workers, let's say they were really hungry and they couldn't wait. They had to stop at a restaurant or something to get a snack and get lunch. So you see they went on this road, and the other 18 says, we got to get right back to the facility because we have another job right away. We have another job this afternoon, it has to be done. So you see that 24 workers came into the job site, 6 went out this way, and 18 went out that way. And that's basically how it works in your electrical system. Right? There's no analogy going on in there, but you have the same thing going on. Now, the traveling workers analogy has requisite conditions, things that have to happen. The workers have to travel to the job site. They must complete the job, and then they must return to the main facility. If 24 workers leave this facility, 24 workers have to come back. And each of these requisite conditions must be satisfied, or you will have an unsafe condition. Now let's quickly just look at a few unsafe conditions. Let's say we're talking about overload. Okay, now what does that mean? Well, let's go back. Let's say a work order was given and there was only one job over here. So the work order was given and it said, well, you need 20 men. All right. But this company here, this corporation, they thought, you know what, while these guys are here, let's have them do more work that needs 10 more workers. In other words, in electrical terms, you would have a 30 amp load here, not 20. So they say, you know what, when these guys come here, we're going to get them to do this work. So you have 30 amps here. You have work that requires 30 men. All right. Now, so they send out 30 men instead of 20. So 30 men get down here on the main highway. And when they get here, the terminal or station manager, he knows that this road is designed for a truck with only 20 workers. Let's say there's kind of a rickety bridge in there somewhere, and he knows this road is designed specifically for only 20 workers to go to this plant or this factory. And they're asking for 30 men to do a job, right? And this highway is designed for only 20, and it can't be done. So this terminal or station manager, he turns the switch off, and that road is closed. He closes that road to stop that unsafe condition. Understand? Now, there's a thing called a short circuit. So how does that work with our analogy? Well, what happens is 24 workers are coming down here to do this job. Remember we talked about that? 24 workers come down here, the main highways, and they turn, and there's 24 workers. Well, either because of miscommunication or ignorance or something stupid, they decide, you know what, we're not in the mood to do this job. To hell with it. And we don't even like our boss. We don't like working here. So we're just not going to do the work. So they're coming in here, and they decide to cut across the median or cut across somebody's property and get back on one of these roads here, either the neutral highway or the red live highway or the red hot highway. Either way, let's say they cut across somebody's property and they do damage. You see here, they're not satisfying the requisite conditions. They're not entirely making it to the job site. They're not traveling to the job site categorically. They're not completing the job. They're creating an unsafe condition. So in that situation, once again, the terminal or station manager here will close the road. He'll close the road, or up here, this manager here will close the road. In either way, there are safety features built into your service entrance panel when requisite conditions aren't fulfilled. In other words, when an unsafe condition is created. So for the short circuits analogy, the workers would come in here and then they would just jump over here to this road and go back and not complete the work, or jump over here to this road here and go back, and that would be your unsafe condition. And that's pretty much it. That's the traveling workers analogy. And I do this as kind of a preface for my next few videos. I'm going to introduce new ideas and new terminology, because in the world of electrical theory, there's all kinds of stuff that kind of doesn't make sense. And just like I did with music and grammar, I'd like to try to clean it up a little bit. So thanks for being incredibly patient, and good night.